video, I'll talk about how to name compounds that contains aldehydes, ketones, functional groups. And I'll do multiple examples just to kind of make sure you get an idea how to do um, most of them. So let's start out with this first one. The very first thing obviously you need to do is to find your longest chain. And since you mainly going to be dealing with an aldehyde and ketone functional groups, you want to make sure that your function group is indeed in the main chain and also gets the lowest number possible when you counting the chain. So in this case, I will be starting from the left side, from the right side, kind of going all the way to the left. And when I'm numbering it, I want to make sure I start numbering it from the right side so that this aldehyde function group gets the lowest number possible. So this one would have been 1, 2, 3, and 4. So on the third position, yes, you do have this methyl group attached here. So you also want to make sure you write down all your substituents first in the naming process. So it would be 3 methyl, and then after that you have a four-membered carbon chain here, so that's going to be, the suffix is going to be butane, and then you got to specify your function group. So since your function group is aldehyde, aldehyde usually ends up with Al, and typically you don't have to specify the position of the aldehyde because aldehyde is always going to be at the first position, so you don't need to say 1 Al, but rather you can just say butane here, and then after that Al. So that is going to be a better way of naming this. Let's look at the second one. So in the second one, I do have an alkene and a carbon-carbon double bond, but then I also have a ketone here. So ketone gets a higher priority than an alkene, so I want to make sure I have the ketone to be in the lower number possible. So that means I need to start counting it from the right side. So I would have 1, 2, 3, 4, and 5. I do not have any substituents on this main chain, so this I can go ahead and start out with pent here. So it's going to be pent. And remember, there is a double bond at the fourth position, so that's going to be pent 4 ene. And then after that, there is a ketone on the second position, so I gotta make sure I specify that. So that's going to be 2, and your ketones ends with O and A. Remember, your aldehydes function groups ends with Al, and your ketone function groups ends with O and A. So that's how you want to name it. You could also name this as 4 pentene and then 2 on. So it's the same way of naming. Either one of those are fine. Okay, let's look at the C here. So in C, just kind of go through the main chain and everything, what I got on this. And it seems like I do have a carbonyl here that's in a ketone function group. And when I'm looking at my main chain, your main chain is going to be, okay, if I start from the left side here, that's going to be 1, 2, 3. And then if I go downward, I get more carbons as opposed to going straight. So this is going to be starting from the left side, going all the way to this middle carbon, and then coming downward to get the longest chain possible in there, or the most number of carbons in the main chain. So this would have been 1, 2, 3, 4, 5, and 6. So I do have multiple substituents there. So on the third position, I have a methyl. On the third position, I have an ethyl as well. So I got to make sure I put those in the names first. You always write down the branches first before you write down the main chain. So in order to put them in alphabetical system, E comes before M. So I would write down 3 ethyl, 3 methyl, and that's going to be 6 carbon chain, so that's going to be hexane. There's no double bond or anything like that. And then your ketone is at the second carbon. It's going to be 2 ONE. Okay, so that's how you're going to name that. Let's look at this D here. So in the D, the functional groups that I got is an aldehyde, and then I can start counting it toward the left to get the main chain here. So your main chain is going to be 1, 2, 3, 4. Whether you go down here 4 or here, it doesn't really matter. So I can say, okay, 1, 2, 3, and 4. So on the third position, I have this methyl. So that's your substituent on that one. So that's going to be 3 methyl butane. And remember, I got to specify the aldehyde functional group, so it's going to be Al. It's at the first position, so I don't really need to specify the number here. So it's going to be butane and then Al after that. So this is how you're going to name that. Let's look at the next one, E. Okay, this is an aromatic aldehyde, and this would be having a common name as benzaldehyde. Make sure you know the common name for this basic aromatic aldehyde. That's going to be called a benzaldehyde. You got a benzene ring and you got an aldehyde function group in there. Like for example, when you name the next one, it's going to be based off the benzaldehyde. So you do have a benzaldehyde here, but then you have a chlorine attached to it. So when I number this, I would start from wherever that aldehyde group is attached to. That's going to be 1, 2, 3, 4, 5, and 6. So on the third position, I have this substituent. So I can call this 3 chloro and then benzaldehyde. Okay, so that's how you name that. Let's look at this next one here. Okay, I got multiple function groups. I got an OH there, while bromine is just going to be in a substituent, and you got an aldehyde. Now, between an alcohol and an aldehyde, you cannot have both of those acting as function groups when you're naming those according to the IUPAC rule. You must have one of them acting as a substituent and other one as a function group. And based on the priority, aldehyde gets a higher priority than your alcohols. So I want to make sure I treat aldehyde as a function group and I treat OH as your substituent in this case. So when I'm numbering this out, I will call this 1, 2, 3, and 4. That's your main chain in there. So on the third position, I have an alcohol. So when alcohol is treated as a substituent, it's called a hydroxy. So I got a hydroxy at the third position, and I got the bromine at the second position, so 2 bromo there. So when I go ahead and put those in the alphabetical order, so this B comes before H, so it's going to be 2 bromo, 3 hydroxy, butanol. That's how you're going to be looking at it. Okay, so then let's look at the next one here. So in the next one, I have ketone as my function group. So then when I count it from the left side, for example, it would have been 1, 2, 3, 4, and 5. That's one way of counting it. But then I can also count it from the right side. So 1, 2, 3, 4, 5. Now, regardless whether I count it from the left or the right, your ketone is actually coming out to be at the third position. And whenever you run into that scenario, you want to make sure your other substituents, if you have them on the group or other function group that you got on the group on the chain, gets the lowest number possible. So if I'm counting from the left side, your methyl that you got here is coming out to be at the fourth position. But if I count it from the right side, your methyl comes out to be at the second position. So that is actually in a better way of counting it and the correct way of counting it. So I want to go ahead and erase this other way of counting it. So then I can go ahead and write it out as 2 methyl, and then it's going to be in a pentane because we got 5 carbons in there. And then on the third position, I got in a ketone, so it's going to be pentane 3 on. Okay, so that's why you want to name that. Let's look at this next one here. So I got in a ring here, I got in a ketone, I got in an alkene, I got in a methyl group. The methyl group is just in a substituent But then between an alkene and a ketone, ketone gets the priority. So I want to make sure I start out with a ketone. So it's going to be 1. And then the next priority will be with the alkene, not with the substituent, but rather with the alkene. So you want to make sure you count it this way, not the other way around. So this is going to be 2, 3, 4, 5, and 6. Remember, your substituents are like, methyls or any alkyl groups and even halogens. They are the least, they're the last in terms of getting the priorities. So um, after ketone here, that would be the alkenes that's getting the priority. So that would be 6 methyl. You still write down all your substituents first. So 6 methyl, it's a 6-member ring as an apparent chain, so that's going to be your cyclohexane. And since we do have a double bond here at the second position, I want to make sure I specify that. So it's going to be cyclohex 2 ene, and then on the first position I got a ketone, so 1 on. Even if you don't write down 1 here, that's completely okay since it's going to be at the first position, but it's okay to write that out as well. This last one here, I got a aldehyde function group, and I got, multiple side chains here. So I got a methyl here and a methyl here and a fluoro here. So when I'm numbering this out as 1, 2, 3, 4, and 5, I can say I have, on the second position, I got a methyl. On the third position, I have another methyl. And then on the fourth position, I have a fluoro. So when I'm putting them together, I'll write down fluoro first. So 4 fluoro. And then I'm going to put the methyls together. So 2, 3 dimethyl, since you have 2 of those. And then I got 5 carbons in the main chain. So that's going to be pentane. And then you have an aldehyde, so it's going to be Al at the end. Now remember, we put those in the alphabetical order, and since we put the methyl together, since because there were 2, just because you put di here, that does not mean it's going to come at first, because D comes before F. The di, whenever you're using these prefixes like di, tri, tetra, they do not. The first letter of those prefixes do not get counted in the alphabetical order. It's typically the name of the main substituents in that case. All right, so this is how you name these aldehydes and ketones, some of the common examples.